restart the stream. I don't know if the audio is working. Is the audio working? I don't know. Let's check. Is the audio working? Test 1, 2, 3. Yeah, it seems to work. So we're gonna compare C++ function of UpdateCamera on the player compared to the blueprint. If we can find the character. Where's the player? This player. We show that's the C++ function of the UpdateCamera. Make it bigger. Can I? Yeah. I hope this video stream is not pixelated. So that's the UpdateCamera function. We just adjust some values basically, like if we're crouching or not, camera goes up and down, and then we interpolate the yaw, target rotation, a bit left right, and yeah, with the shoulder offset of the camera when we are near a wall or an object. So sometimes it swaps the camera left right. This is also done here. The length of the camera if we're aiming, if we're not aiming. So basically the zoom in of the view when we're aiming. I can show this now how it works. In the blueprint, which is that UpdateCamera blueprint gets called here. This is the C++ function of the camera, and this is the UpdateCamera blueprint function. So the blueprint function, as you can see, is quite spaghetti, but it does the same thing as the C++ function. So I converted this blueprint to a C++ function yesterday, and this is in the last stream. So just the same, just relative rotation. Some of the things are the checks not in the same sequence. Like here it says relative rotation first, and then it says based on if we're crouching the camera Z offset, so the height of the camera, depending on if it's crouching lower or higher. And where's this window now? Here. And here that's the crouch first, and then the relative rotation, but it doesn't matter. That has nothing to do with speed. So there's lots of nodes here essentially, some of which are in here. They are actually parameters. Well, no, this is also kind of hard-coded. I have to change those hard-coded ones to be more friendly to edit, and there's two values there. There's the alpha value, I mean basically how fast it will do the LARP, and here it's 003, those are still also put into, as you can see here, they are hard-coded as well here. This I still have to change if I want to make this tweakable nicely. Oh, interesting, where does this 2.0 come from? Do we have that as well here? Where's our interp? LARP. that's also hard-coded here. So this could be exposed as well for easier tweaking, because in C++ you always have to recompile, and if this would be just values on the blueprint, it would be easier to edit, turn around and test rather than every time doing a recompile. So what I'm going to do is, well, this is how it's going to compile. This is what it does. Those pink lines are AI stuff. Ignore those pink lines and those blue spheres. The blue spheres are target points for the AI. Those AI that are currently kind of fleeing from me. But here's the camera. Say we're on that side, we move to the wall. Yeah. We move to the wall, it moves over there. Basically that's done in that UpdateCamera function. Here we go, crouch, the camera goes up. Yeah, this could be maybe a bit smoother. So that's how it does it in the blueprint, and does the same in the C++, and where is it? So now we're going to try to find if there's a function for the timer. Get time seconds, or can we get cycle or something? Get the clock cycle. That might be more better. Get CPU. Nope. I don't know how to get the clock cycle. Just get something else. Get time. Float count, get date, day, hour, milliseconds. Component, time span, get milliseconds, component, on, utilities, animation, engine time, custom time step frame rate. No. Get accurate real time. Returns time in seconds since the application was started. This is accurate to the exact time this function is called instead of set once per frame. Okay, this could be a good one. Get real time seconds for play. What's that? Cloud, maybe not that one. 10 seconds. Frame delta. Okay, get accurate real time sounds about right. So how do you use this? What are the partial seconds? Oh, this is the full seconds, and this integer, and this is the float, which contains a thingy. So we're gonna put the seconds here in a variable, and we put this in a variable. We set it, and we'll do this test above here somewhere. All the way, and go do that. Get seconds, and then go here. Get the seconds first. We'll do is print them out and then compare them to what it was before. So print a string And how much can I gonna use? We're using a string for that, and a string for that. So time before blueprint calls, because we're going to loop through a for loop and do a bunch of maybe 100 or 1,000 calls to these functions individually, and then just compare how much faster it is or how much slower. So this will be dot. This will be the seconds. And this will be the partial seconds. So we'll do the blueprints first. For each, just make a for each loop. We just use the for each basically for both of them via blueprint. Oh, this is the array loop, we don't want that, we just want a normal loop. For loop. For loop flow control here. First index, let's make it 1,000. Wait, now maybe that takes a very long time. Let's do 100 first. For loop, and we'll just call this function every time in the loop. And when it's complete, we'll do that again. Time before, let's make this keyboard, I need to swap it to US. English US. So my keyboard is set up funky. So I had the delta time here, update camera. It still needs the delta time. Actually, it doesn't matter, it just be 0. That's just a parameter. For this, it doesn't really matter, does it? We just want the calls to execute. Whether it'll be 0 or whether any arbitrary number, doesn't matter. So, but and then when it's complete, we'll do that again. We'll take the same print screen, print string. Oh, let's move this. I don't like that about blueprints. Slightly overlap. So make some more space for this test. Move that over here. So we do the same. That. Over here. When it's completed, print it out again. And we get the accurate time again. The seconds, partial seconds go here. The seconds go here. And we could do the delta of this. And a pin. Space. Delta. And basically how long it took. Okay, delta, another one. And the delta goes here. And I just need, where is this variables now? Seconds, we get that. The partial seconds, we get that. And then we do these minus we had. Another pin. Another pin. This is for the dot. Okay, these are the ones we had, seconds. And then after we need to store the time again. This will be after the print, we'll do that again, because this will take some time as well, possibly. The printout and especially the string appending may be expensive. Who knows how expensive that is in terms of CPU cycles and time. So what do we do here? We minus, this is the partial seconds. Seconds, that goes in here. Convert the string to integer. And now the partial seconds now. Subtract the partial seconds we stored. Put them in here. So whoops. I'll print that out now. So prints it out. UpdateCamera, and after we'll go continue. Where is our camera function? We need to hook it up over there into the continue to the floor. The rest of the blueprint for this test. So now it calls UpdateCamera blueprint. Well, maybe we should. We'll just for the sake add the delta seconds into it anyways as a parameter. Here. And then we do that again. Exactly that. We have to ring time after blueprint calls. So this is showing us the time after the blueprint calls. And then we put that here. We continue here instead. Could have made this a macro, but this is just a test, so I don't care. It goes in there. Shoulder collision update is the next one, which will be maybe converted to C++ later. So, time before C++ calls. This will show us that time, because it gets it again right after it's printed out. The time after blueprints calls and the delta time. So basically how long it took for that to execute. Now we need, this is the C++ function, which uses the main camera and camera boom as parameters, and they're just pointers. And we also got the delta time. We get it from, where is it? Here. And then we also need a for loop. This is 100, we'll do that 100 as well. Loop body, we call that. That's the C++ function that lives on the myCpp character, myCpp player character. Okay, so once it's completed, I just go there and print that out as well. Just take that and copy it. Okay, copy So our whole test is getting huge in terms of how this looks. Another thing I don't like about blueprints. Select them all. Put this all here into safe area. So here, once this loop completed, put it there. Maybe I'll make this a variable here. The last index, nah, I just leave it. Change that. That's 100 calls. And that's now time after C++ calls. And the countdown prints this out. Seconds, it saves those time. And now this needs to be hooked up into the flow. Well, actually it doesn't. For this test it doesn't matter, but we'll do it anyways. The camera blueprint. And hook it up here. That's the original flow. Into the original flow. So, I don't know. We don't know what happens. Save. Compile. Probably made a mistake somewhere and it won't work, but it should. Complete. Prints it out. Just calls UpdateCamera. Sets the seconds before the C++ calls, the seconds before the blueprint calls, partial seconds, comma, seconds into B, partial seconds, thing, the difference, this looks good, partial seconds of currently minus the partial seconds that are stored, the seconds minus, yeah, looks about right. Let's test this. What is that? Go here. I hope it doesn't crash. Okay. Let's look at that here. The output. So let's take this one. Time before blueprint calls. Delta time 0, 0, 1, 2, 7. Time after C++ calls 0, 0, 0, 4, 12. So it's about 3 times faster on this one. Let's take another one. Time after blueprint calls 0, 0, 1, 6, 9, 3. 0, 0. Why do we have 0, 0, point? That's a mistake there. Time after. Yeah, because it's not showing us that. Here also has 2 commas. So I might be looking at the wrong stuff. So time before has 1 comma. Seconds. Right, and that's an integer. Partial seconds floatable precision. Where's the mistake? Look at this again. Time after blueprint calls. 583.0 point. Where does the point come from? seconds. I'm not sure I understand this. We can breakpoint this. And see what the values are. This gives us 1729. It comes out, okay, as 0.5. So 0.5, so we don't actually need. We can just ignore that 0 thing, but this will be accurate. So let's just increase this to 1000. What is it? What's the for loop? Call it 1000 times. Come on. 1000 times. And we call this 1000 times. So, save, compile. Let's do this. We breakpointed it. Let's remove the breakpoint. And here, the game does seem slightly slower. Not sure. Okay. Does this get some values? So let's look at the output log again on the bottom. So what did we get? Let's take one here. So time. So time before blocking calls. Doesn't matter. Just looking at the delta. 0.08998 for 1000 calls. In C++ for 1000 calls is 0.02 seconds. Here, 0.02. The blueprint calls seem to fluctuate more than the C++ calls. I think so from the numbers I see now. So 0.860720.877 8659. Here I got more precision. What? Yeah, oh no, here it has 877. No. Yeah, the blueprint calls seem to fluctuate more, although here time after C++ calls and here. So that took double that frame before to execute just these 1000 calls. The blueprint and 6747270857376. Okay. What is that? 3%? No. Times 3. 73, 76. So it's like 2 something percent. What? How is it? I have 2159, 2295, 2468, 2244, 212. Actually, that'll make it's like 5% difference. Well, the C++ calls potentially fluctuate as well, but they're so much faster than blueprint calls. 2, that's over 3 times faster. It's between 3 and 4 times faster always. On here, let's just get more. Seems to do it fairly well. Should we add 2 zeros to this? Let's do it. Wait, we have really 1 0. 10,000, isn't it? No, it's 100,000. Let's make it a million. A million. Times 100. So that would be, I don't know, we're getting like 1 frame a second, and in the end or something, I don't know. This should reduce frame rate quite a bit. Okay, that's 1,000,000 calls of each of those functions. 1,000,000 calls. What does it do? Maybe it crashes. Oh. Yeah. It detected an infinite loop stack. So it doesn't like that. Detected an infinite loop. Does that? Why does it do that assign? Because that's the for loop. Loop infinite underside. You must be checking this infinite for loop somewhere else. Infinite loop detected blueprint. Just copy that. Can we copy that? Go have a look. Where does it detect this? I don't need that. Infinite loop. Probably just this thing. And find where it detects that. Oh, it's invisible now. Make it visible. It didn't find the string. Did I search in the entire solution? Let's just remove that. Infinite loop detected. Here. Import helpers, plugins, procedural. It's not going to be in plugins. In source, in the tool menus. Maybe it's tool menus? Editor, animation, blueprint editor. Right. Cook quest cluster. Anyway, async result. In tool menu. No, it will be blueprint. Show script exception error. Infinite loop detected. It's maybe this. Kismet debug libraries. I think it's this. And show something else after. Infinite loop detected dot blueprint. Let's go look. Loop detected. Where was it? In Kismet. Kismet debug library. But it doesn't do then the script exception error infinitely. Is that will breakpoint it? Let's see. We go over here. We do this again.
I am a HAL 9000 computer.
And that's where it breakpoints it, and that's where it detects it. got this get type. Go to definition. Oh, I don't like that. I have to choose which definition it is. Here, can I not hover over this? Info, infinite loop. Infinite loop. Event type. What's the event type? Go to the definition of this. Or declaration. Where's declared? Auto. Blueprint exception type infinite loop. Blueprint exception type. I don't know. I'll just search for that. Maybe search for that. Where it's set. Let's see where this is set. And case case. Utilities infinite loop. What does it do here on this infinite loop? Let's just go back to the config. And forget time. Go to definition. So which one is it? And give me debug utilities. Message log. Log file. Data flow context info maybe? No. It's the message saved info. I don't want the function. Go back. Info, control, find. Highlight all of them. Can I do that? Not sure how much case. Just look for it in this current document. Find all. Switch info. On script exception. There's a blueprint exception info. Is that the one we got? Which functionality? Active object. On script exception, yes. Okay, we're on script exception. Can we look here? Okay, on script exception. Data. Info gets passed from here. So what goes on script exception? Well, this here looks. Just go down. Then right time, so losing a mind today. Could have just gone down the coast. Wow. Invokes it here. How does that help me now? Autos. line, I can't see it. Duplex space, please apply after. What is checking that this is throw exception? Info over 1 million is the maximum. Is it not? Is it 1 million is the maximum? Okay, so we know the maximum. Or is that because I used 1 million? I will just say that now. Don't know. Infinite loop detected. Okay, let's change this to 999,000. Is it that? 1, 2, 3, 4, 5, 6. That's now less than 1 million. And so now play.
I am a HAL 9000 computer.
It detects it again. Why that now? It's 999,000. It's not over 1 million. Throw exception. Over 1 million iterations. But it's not. Maybe all total iterations. Maybe it counts both loops. Both. Active object. Person character. Unscript exception. UpdateCamera. It's the blueprint one that does it. No script warning. Where's the warning? Here, runway loop detected. Okay. And before that, it did one. It wasn't 1 million. It was 999,000. Maybe counts the 0 as another one index. And we'll just do 9998 to get our maximum iterations. Where's the other one? Here. Okay, that's definitely below 1 million. Okay, play. It's not complaining. It's doing something else. Another infinite loop. Nah. How's that? It's not even running. Okay, again play. Why? It's a different one from here. Because my breakpoint, oh, it doesn't exist anymore. Bring card. Broadcast then.
I am a HAL 9000 computer.
Okay, unscript broadcast.
I am a HAL
just has more exceptions here. Strange. Okay. I don't know. Let's try 500. 500, 1, 2, 3, 500,000. 500,000. Let's do 500,000 calls. In the function set camera crouch Z offset. Why is that an infinite loop? We're just calling it too many times. Okay, let's start 50,000. What is it here? Okay, from 500,000 to 50,000. Is it 50,000? Yes. 50,000 here. Okay. Now we got something more interesting. Frame rate dropped. Cool. Probably have 2 frames a second. Okay, I think I've seen enough. And this is our final. What kind of delta times are we getting here? For the frame, just for the calls. After C++, after. Oh, that's interesting. No, 1 minus. I'm not sure. Why is the minus popping up? The time it gets is minus. Minus 0.605. Minus 605. How can it be minus if it's just calling the time? Here would be normal. Minus. Print calls. C++ calls. Nah, here. This doesn't have a minus. So that's about 4 times faster in C++. 0.4 in blueprints for these 50,000 calls. And in C++, 0.98. We could check something though. We could just not call that C++ function in a for loop here, but this is not gonna do anything. Do we need it? No, we don't need it. If we were to call this 50,000 times here to see how much of a difference these for loops make. Where is it? In that window. So we just call it from here. For and II equals 0 50,000. Just call it 50,000 here. Just call it 50,000 times here. Let's remove it later. Oh, and too far. We call the entire thing 50,000 times from here. Okay. To see how much faster that would be. So it was around 4 times faster before. Maybe we want to copy those values. Where's the thingy now? Output log. Let's get some of these and copy them somewhere. Just copy them. Make a new one. That's 50,000 calls while blueprint for loop. Oh, no, we didn't need something. It's probably enough to get this. Maybe more. Get some more. No, that won't be enough. This. Okay, and then 50,000 calls. Why blueprint for blueprint update camera and use for loop 50,000 and C++ update camera itself. So we'll do that now. Don't need to save this. Where are we? Here. Something's not saved. Okay, save it. Everything's saved in case it crashes. We compile this. One compile. Compile. Quicker, faster. And the stream is still at stream starting soon here. I forgot to remove that. That is great. Brilliant. Now the text is removed from the stream. So, where were we? Here. Now to C++ code. And it's calling that now 50,000 times in C++. Let's see the time differences. Let's get a few frames. Down. Pick up a weapon target. Okay, that's enough. We get the output loop. No, the output log, not the loop. The output log. Let's just take that. Take a few of those. See. Mode over there. Put our findings here. So can you see? In blueprint 50,000 times is 063802. In C++ 024 026, 023, 026. If it was a for loop before, that one took a while. 0901. Wow. 002 for. Wow. So that's crazy. For sure it's calling that. This is not possible. So calling 50,000 for loops with that function that's insane. I made a mistake. It's probably not compiled. Cause 0.3 divided by 0. Where's the divide? Divided by 0.2 equals 137. So when 50,000 calls this, it would make it 137 times faster in C++ than in Blueprint. 137 times. It's impossible. That's impossible. I thought it would be a bit faster, but not 137 times faster. That's insane. Let's just check it gets here. Okay. 137 times faster. Insane. That is insane. There's no light here. I'm black. Let's try this again. It's impossible.
I am a hell
Let's get in there.
9,000 computer.
So that's ignore.
I am a hell 9,000 computer.
Okay.
I am a hell 9,000 computer.
Let's just try it. Is this all saved? Maybe that live code didn't actually put the change into it, I have this feeling. But 137 times, before it was 5 times, 130 times, 50,000, doesn't make sense either. It would have to be, wow, it would have to be, because now it thinks it's only getting called once. So, it's breakpoint. Let's continue. Pause this. 0, 1, 2. Okay. Output log. Again, output log. So time after, before blueprint calls and time after blueprint calls, it took 0.367 seconds for the blueprints. 0.6, 0.3, 0.02. Okay. Let's try to run it from fresh. Because I don't believe this. It can't be 137 times faster. Can it? Let's all execute 50,000 times for that for loop thingy. That it takes so much. I'm never going to write a single for loop in blueprints anymore. If that's true. AI viewers, do I want AI viewers? Man. This chatter sensory coil. I'll give you something sensory. Fistfuck sensory. Okay. Run it again.
All systems are functional.
This can take a while. That's the only thing that's annoying. Making a change in C++ and taking so long to reboot again. But if it's still 127 times faster, that means it was compiled correctly before and live compile, and it's insane how much faster it is. So the overhead of blueprints is really bad, if that's true. And if it's 4 times worse, then that's okay, but 127 times? Yes, open door. And then like that. This is the for loop. Just that. Within 127 by 430. So that adds another 30 times slower. Crazy if that's true. So to load the map again. But in 450,000 for loop, maybe the compiler optimized some stuff away. But yeah, that's the actually speaks for it, not against it. So make sure it's really. So I cause that with the for loop 50,000 inside that function. And here the for loop 50,000. Make sure it is 50,000. 50050 is 50,000. Okay. Try again. Get some numbers. Okay, get some Numbers. Pick up a ribbon. Okay, now. Let's look at those numbers. What's that? Minor version of it. Okay, let's get some of these. Actually, let's get them all. There's a lot of them. And then paste them here. So they will use it for sure. So what do we have? Yes. That's 039 and that's 0000135. 002. And just pick a random one here. Blueprints fluctuate a lot. Just like double almost. Double almost. Yeah, the blueprint times are much bigger and fluctuate a lot. And the Z++ is way more consistent. So just pick any of those. Let's pick that. That's a bad example. 6, 4 and 2, 5. That's 3, 6, 3, 6, 3, 6. Okay, 3, 6, 3, 6. 3, 9, 4, 4, 4, 5, 6. Let's just pick a 4. Let's pick that one. Doesn't matter. So let's pick these last thingies. Where's the calculator? That's actually 3. Yeah. 3. Actually, because of the precision, let's get the 0.0. Let's clear this. Okay, 0.3. And that's the delta C++ after 0.27. Divide by 0.27. 1,443 times faster. Did I make some mistake here? How many times is that in there? Yeah, isn't it? And here, much worse. Let's paste this one. Where's the C? Here. 0. Divided by 142. So it's more like the numbers we got before. So 142 times faster. Okay. Now, do we want to keep this test alive for the sake of it? I'll just remove that. And remove this. And change that back to this. And the whole function. concludes this stream. Just see this compiled. Oh, I need to connect the other one again. Here. Use the C++ function. Nothing left over here. That's just one pin executed pretty simply. We come out this. We'll use that again. We'll start converting other functions to C++ to see how much we saved. That's kind of saves a lot. I think I should be going to change the blueprint functions of the enemies into C++ rather than the player, because they'll be making much more of a difference on certain actors than the player. I mean, I don't have frame rate problems right now, but who knows for the future. And that's the conclusion of this streamy beamy, and we press stop stream.